Good morning, students. How are you? Today, we will be talking about the states of matter, characteristics of solid, liquid, and gas, and why matter exists in three different states. Also, comparative study of the characteristics of solid, liquid, and gas at the end. Right now, let us understand the states of matter. As you know, matter exists in three states. Number one, solids. Solids are the substances, for example, bottle, chair, table, bus, books, etc. Number two, liquids. Liquids are the substances like water, milk, fruit juice, alcohol, etc. Number three, gases. Gases are the substances like oxygen, nitrogen, carbon dioxide, steam, etc. Now, let us talk about the characteristics of solid. Dear children, solid has a definite shape, like the things like cups, saucers, spoons, tables, chairs. They are solids and they do have a definite shape. Solids have a definite volume. If you think of a wooden stool, ask your friend to sit on it. After your friend sits, does the volume of the stool change? No, it does not. Another characteristics of solid is that solids may get heaped. For example, if you take the bowl of a common salt, empty it on the plate, what do you see? The common salt does not flow. It gets heaped. So we can summarize that solids have definite shape, solids have definite volume, solids do not flow, they get heaped, solids do not need a container to hold them. So we can summarize as a material that has a definite shape and definite volume such that it can have any number of free surfaces is called solid. Now let us talk about the characteristics of liquid. Let us understand this with the help of this activity. Take small conical cup, as you see in the picture, and fill it with water. See the shape of water. It resembles the shape of conical cup. Its top surface is free and flat. Means it has only one free flat surface. Now pour this water from conical cup into the bowl. And what do you notice? You notice that the water flows into the bowl and takes the shape of the ball, while its top surface is free and flat. Top surface is free and flat. Now pour the water from bowl to the small bottle, and you see the water flows into the bottle and its top surface is free and flat. Top surface is free and flat. From this activity, we come to the conclusion that liquids take the shape of the container and have only one definite free surface. When the liquid was put into the conical cup, it took the shape of conical cup. When it was put into the bowl, it took the shape of bowl. When it was poured into the bottle, it took the shape of bottle. Alright, now if we see the another picture, figure 1.7, let us conduct the another one activity. We take a disposable syringe. We fill half of the syringe with water by drawing the plunger outward. Close the bottle of the syringe with the rubber cork. Now push the plunger inward with maximum force and record the observation. Now stop applying force and record the observation. What do we see? We see that the plunger does not move inward on the application of the force by thumb. When the force is removed, the plunger does not move backward. So thus, the volume of water does not change. So, we can come to the conclusion that liquids do not change their volume when compressive force are applied. Now, we have come to the conclusion that liquids have these characteristics. Liquids have no definite shape. Liquids have definite volume, yes, and liquids have only one definite free surface, which is on top of the vessel in which they are contained. Liquids cannot be compressed, and liquids always need some container, otherwise they start flowing. So we can say about the liquid that material which has a definite volume but no definite shape and has only one free surface is called liquid. So now we will be talking about the characteristics of gas. Look at this picture. What is there? A balloon, a football, a plastic doll. And what we do? We inflate all of them with air and see that all of them are filled with air but are of different shapes. That is, shape of the containing vessel, balloon, football and doll respectively. So what we filled inside this and inside this air. So this activity suggests that air means gas have no shape of their own. It takes the shape of the containing object. Now consider this picture. Some incense sticks, they are put on in the stand, and the stand is placed in one corner of the room and all the incense sticks are lighted. And see, we will be able to smell the odor everywhere in the room. Though we kept all the incense sticks in the corner of a room, but from every part of the room we can smell the odor. So we know by this that the gases have no definite volume. Gases expand to fill all the space that is available to them. Now if we consider this picture 1.7, what do we see? We see the disposable syringe, which is half filled with air, by drawing its plunger outward. Close the nozzle of the syringe with the rubber cork. Push the plunger inward. With the maximum force applied by the thumb. See what happens. The thumb is not able to push the plunger somewhat inward. After the compressive force is removed, the plunger again returns back to its original position. So, out of this activity, come to the conclusion that air is compressible unlike solids and liquids. So, we can summarize it as the gases have no definite shape, gases have no definite volume, gases have no free surface, and gases can be easily compressed. So, we can define gas as a material which has neither definite shape nor definite volume, is easily compressed, and has no free surface, is called gas. The next topic, why matter exists in three different states. Why matter exists in three different states? You know, my dear children, matter exists of extremely small particles. Matter, it consists extremely small particles which are not visible. We cannot see with our naked eyes. The smaller particle of matter which can exist independently is called as molecule. The molecules are in the state of continuous motion. You know, they are very crazy. They cannot remain silent or stationary at one place. They are continuously in motion. And this motion does not stop with time. And due to the continuous motion, all the molecules have a kind of energy called kinetic energy because of their motion, continuous motion. The spaces in between the molecules are called intermolecular spaces. The molecules attract each other with a force called intermolecular force. The intermolecular force increases as the intermolecular space decreases, and intermolecular force decreases as the intermolecular space increases. Now, if we take the example, when we hit ice is a solid, so its molecules begin to move faster. Molecules are already in motion, but when we start heating it, molecules begin to move faster and farther apart until water reaches a liquid state. It was in solid state ice. If we continue to heat the liquid, what will happen? The molecules move even faster and farther apart to become water vapor, means gas. Now, if we speak about solid, the intermolecular force is very strong with negligible intermolecular space. So, the molecules are not free to change their positions. So, they are tightly packed. So, the solids have definite shape and volume. Solids cannot be compressed because it's very strong intermolecular force and negligible intermolecular space. If we talk about liquid, in case of liquids, intermolecular force is weak and intermolecular space is more as compared to solid. So the molecules are free to change their positions within the liquid. The molecules cannot move apart. So in this way, the liquid has definite volume but not a definite shape. It can flow and needs a container to hold it. And when we speak about gas, in case of gas, intermolecular force is negligible and intermolecular space is far more as compared to liquid. So the molecules are free to move in all directions and can fill the entire space available to them. They need a container to hold them. So, dear friends, gas has neither definite volume nor definite shape. It is easily compressed due to maximum intermolecular spaces. And at last, see, this is the comparison between the characteristics of solids, liquids and gases. So this is for your convenience that we talked about the definite shape of solid, shape of liquid, shape of gas. What is the position of molecules in case of solid, liquid and gas, whether which can flow, whether solid can flow or liquid or gas. What is the intermolecular forces in case of solid, liquid and gas. What is whether solids can be compressed, how liquids, and what about gases, okay, and holding, which solid can be or liquid or gas can be hold in the container, and about the free surfaces, in case of solid, in case of liquid and in case of gas. Achha, one more thing I want to tell you dear about these pictures. See, these are the arrangement of molecules. When we speak about solids, the molecules are very close to each other. But when we speak about liquids, molecules are a little away from each other. See, as the molecules are shown here in this picture. But when we speak about gases, see, the molecules are far apart from each other. So here the intermolecular force of attraction is much. In case of liquid, intermolecular force of attraction is lesser than the solids. But if we talk about the intermolecular force of attraction in gases, it is negligible. So in this way we come to the end of today's talk. We talked about, I just give you a recapitulation. We discussed about the states of matter. We talked about the characteristics of solid, liquids and gases. We also talked about the matter, why it exists in three different states, why matter exists in solid, liquid and gas, and also a little comparative study of solids, liquids and gases. I will come with another interesting video about physics in the next video. Till then, take good care of your health, and don't forget to like, subscribe and press the bell icon. Okay, thank you children. We'll meet again in the next video. Till then, bye bye.